Hello and welcome to this week's Solution Saturday. In this video, we're going to go through question 40 from the Consortium Group 2 2015 paper. Make sure to check out the other videos in the playlist for more worked solutions for this paper, and subscribe so you don't miss out on any of our other videos. Nicole likes palindromic numbers. Palindromic numbers read the same backwards as forwards, and we've been given some examples. 11, 22, 33, 44, and 55 are all palindromic. What is the smallest multiple of 11 that's not palindromic? Well, if you know your 11 times tables, you know that if we multiply any number from 1 to 9 by 11, our answer is going to be palindromic. However, if we multiply 11 by 10, we get a non-palindromic answer of 110. So that's our answer, 110. What's the smallest number larger than 1,000 that's palindromic? Well, 1,000 is not palindromic, so let's move on to the next number. Luckily for us, 1,001 is palindromic. Can you see how? So that's our final answer, 1,001. Which two palindromic numbers less than 1,000 have a difference of only 2? If you take any 3-digit palindromic number less than 1,000, for example, 999, the next palindromic number along would be 989, but they have a difference of 10. This is a pattern that's valid for all 3-digit palindromic numbers. If you take a 2-digit palindromic number, such as 99, the next palindromic number along is 88, and these have a difference of 11. This is also a pattern that's valid for all 2-digit palindromic numbers. We obviously can't have a 1-digit palindromic number, so what we need to do is use the process of trial and error to have one 2-digit palindromic number and one 3-digit palindromic number. For example, we could have 88 and 101, but they have a difference that's far too great and much greater than 2, so we can't have that. If we move the numbers closer together, we could have 99 and 101, and they have a difference of 2. So that's our answer, 99 and 101. The palindromic number 131 has a digit sum of 5, since 1 plus 3 plus 1 is equal to 5. What is the only other palindromic number less than 1,000 which has a digit sum of 5? After a bit of trial and error, you may find that there are no other numbers in the 100s which have a digit sum of 5. So we need to go up to the 200s. As we write the 2 as our first digit, we know that to make this number palindromic, our final digit also has to be a 2. 2 plus 2 is equal to 4, so we have to have 1 as our final digit to make this digit sum 5. So our final answer is 212. List all of the palindromic numbers between 1,000 and 1,000,000 which have a digit sum of 5. For this question, we need to use similar workings to the previous, and we need to be systematic. In the thousands, we know that the first digit has to be 1, and to make this a palindromic number, so does the last digit. However, we now have 2 digits in the middle to make all of the digits add up to 5, and this is actually impossible, so we know that we can't have a number in the 1,000s. Let's move on to the 2,000s. We need a 2 at the beginning and a 2 at the end, so that the number is palindromic. The 2 digits in the middle would have to add to 1, and this is also not going to work. Therefore, it's impossible to get a 4-digit palindromic number whose digits add to 5. So let's move on. Let's move on to the 10,000s. Here, we need a 1 at the beginning and a 1 at the end. We now have 3 digits in the middle to add to 3, so we can either have 10,301 or we can have 11,111. These both work. There's no other way to get a 5-digit number with 1, so let's move on to 2. We have 2 at the beginning and 2 at the end. We have 3 digits in the middle, so now we can have 20,102. We can't go any higher to the 1,000,000 limit, as we'd run into the same problems we did with the 1,000s. our digit sums would just get too high. So these are our final answers. Thank you for watching. We hope you've been able to gain valuable skills that you can apply to problems similar to this one. If you have any questions, don't hesitate to leave a comment or reach out on our other platforms. Check out the other videos in the playlist for more solutions on tricky questions from this paper.